Remember this rule. Square root of x is x to the power half. Nth root of x is x to the power 1 over n. Hopefully that's okay. And then we're still using the same rule to differentiate x to the power n. Bring the index down. Subtract the index by 1. Okay, let's try this. Starting with the square root of x. X to the power half. dy over dx. You get half x to the power negative half. And you do one thing at a time. Half times 1 on x to the power half, which is 1 over 2 root x. Okay. Right, cool. That's pretty good. Now, the square root of x used a lot in many expressions. So the textbook suggests that it's useful to know this result, as in you memorize this result. So if I see differentiate square root of x, remember that. I think that could help you, but you don't have to, because that may save you time. Again, students may choose whether or not to memorize it as a special result. So it will be good to memorize it. But if you don't want to, then that's okay. It just takes you a little bit longer. Okay. But the other one you don't have to memorize, but this one's good to memorize so that it saves you time. It can save you time. Okay. Next one you go like this. So this is the 1/3 x squared, which become x 2/3. Yep, x 2/3. And then you differentiate. I just write y dash 2/3 in front. Subtract the power by 1, which is negative 1/3. So you get 2 over 3 times 1 on x to the power of 1/3, which is cube root. 3 cube root of x. That's it. That's all you have to do. So it's the same, using the same rule, just fractional indices. And they will ask you a question about when is the tangent horizontal. So you will see the calculus can be a bit boring. At the beginning, it seems exciting, but then after that, it's all very mundane. Just to use the same rule. And they always usually ask the same question. What point the gradient is 0? Something. Find the equation of tangent, etc. Okay, next one is x squared. So x squared, and then times x to the power half. And you should be using improper fraction, 5 over 2, instead of 2.5, because it's easier to times by improper fraction than a mixed fraction. So write 5 over 2, then you do dy over dx, you get 6 times 5 over 2, x to the power of, subtract that by 1, is 3 over 2. And then the 2 and 6 get cancelled. 3 times 5 is 15. Like that. I think that's okay if you leave it like that. If you want, you can write it in root form, which is like that. That's the root form. But you don't have to. This or this are fine. And try the next one. Have a try before you look at my answers. Have a try. So if you're a person who does things very quick, use the opportunity while you're waiting is to try the next question. And then say, oh, I got it right. That means I know it. That's good. So that means I can do the homework. I'm more confident to do the homework. So the next one uses the similar skill we had before. Again, do a step by step. 2/3 times 1 over x root x. And root x is 1 over x to the power half. Notice that I do things very slowly, one thing at a time. People say, oh, let's multitask. Yeah. People just make silly mistakes in the exam. Yeah, I don't think it's a good idea. Yeah, you could multitask sometimes for certain tasks. They complement each other. But if you multitask these stuff, quite a few occasions, people just make this careless error. Like that. See, notice that takes 3 steps. Yeah. You should try to make, yeah. I mean, you may be able to skip all these steps, but that's probably after you would do a lot of questions. I wouldn't go through, if you haven't done a lot of questions, I wouldn't recommend skipping all these steps. You should show every single step. But if you've done it so many times, you can do it in your sleep, yeah, of course, skip the step. Yeah. Okay, so you do dy on dx is 2/3 times negative half, and be very careful when you subtract 1 from negative half, that will be negative 3/2. So if you can do it in your head, that's negative 3/2. Yeah. Or you can use a calculator. So the 2 get cancelled, you get negative 1/3, x power negative 3/2, which you get, again, bring it down. Again, I think that's okay if you leave it like that, but sometimes you do have to get rid of the negative index and write it as a root form, which is square root x cubed. Yeah. Make sure you write the 3 very big, because there's a difference between cube root and 3 times square root, if that makes sense. So that's 3 times square root. Okay, write it down. All right, hopefully it's okay with people. I'm going to do E now. Now, E, there's 2 methods. So again, if we were to use this result, that will speed things up. If not, you will just make it a little bit slower. For example, if I were to use this result, this will be very quick. Watch this. You will obviously use a chain rule. So do dy on dx, 4, 1 plus root x cubed, right? And what's inside when you differentiate? Oh, this thing, if you remember that, it, right? See, it's very convenient. And the 2 get cancelled with 4, so you get 1 plus root x cubed over root x, right? There's a 2. The 2 and 4 get cancelled, right? If you, that's method 1. If you choose to use the shortcut, which you're encouraged to do so, but you don't have to. But if you don't like the shortcut, then you have to use the chain rule. So you will still do the same thing. You still do 2, 1 plus root x, 4, sorry, like that. But you have to write x power half. If you differentiate that, that will be half x power negative half. It's just a bit more algebra. I think that's, you just cancel negative half, and negative half means 1 over x cubed, 1 over something. It's just more working out, that's all. And that's just square root. Yeah, like that. All good? So that's method 2. So that's why it's good to remember the square root formula, but you don't have to do that. You can just do it step by step. So it's up to you. But I chose to do, I remember it when I was young, because I think it will save me time, particularly when there's a chain rule, when there's a root x inside, that will help me to do things a bit faster. And followed by 3 more examples. Yeah. Which is, I'm very excited to announce, to see that, actually, yeah, we'll leave it there. Because some of the formulas we can now relate back to exercise 9a, where we find the gradient of the tangent to a semicircle. We can now do it with chain rule. Right, let's move on. Okay, so relate back to 9a. So remember, this is a semicircle. So semicircle like this. And if we were to find the gradient of the tangent, we'll first find the gradient of the radius, which is gradient of radius is y over x, y over 1. And gradient of the tangent will be negative reciprocal. And the negative reciprocal y is this thing, right? Y is the square root 4 minus x squared. That's from exercise 9. And now, you're not recommended to do this. This is just there to give you something extra to do. So this is exercise 9a method. Now you can see where that comes from, using the chain rule. So everything relates, right? So let's use the chain rule dy on dx. So you take the half down, 4 minus x squared, negative half. Differentiate what's inside, right? Negative. Although actually we'll just keep going. So that will be the 2 and negative get cancelled. So you get negative x, 4 minus x squared, and that will be the negative half means square root at the bottom. I skipped some step. I'm sure you understand me. So you notice that you get the same thing. Same. Yep. Notice you get the same thing. All right, so that's pretty cool. I would like to show you the second method. Remember that if you differentiate root x, it's 1 on 2 root x. I could even use that in the chain rule. And in the chain rule, when you see that, that will save you time. Watch this, dy on dx. You have this structure, 1 on 2 something. Get the idea? See the square root, 1 on 2 something. Then differentiate what's inside, which is negative 2x, which I think will save you time. So that's why, because square root occur a lot in maths. So it's good to know a formula for the derivative of square root without going through all the index law, just to save you time, right? Cool. Hopefully that's okay. And then try the next one. So you see why, see that actually verified that the formula is correct, what we did in exercise 9a, right? Perpendicular to the tangent. Okay. All right. Once we do that, we'll do the next one. The next one, you can't use that fast trick because it will be a negative index. And negative index is completely different from a positive index. So you have to write negative half instead of positive half and then go through the procedure. Have a try. Right, so we'll do y dash is negative half, 1 plus 4x squared, negative 3 over 2, times 8x, right? 2 and 8 get cancelled, you get negative 4x. And then the negative goes down over 1 plus 4x squared, 3 over 2. Therefore, you get negative 4x cube root of, oh, not cube root, sorry, it's a square root by cube. All good. All right. Yep, all good. Yep. Okay, try the next two again. It's like the question we did before. Differentiate. Again, you have to split the fraction and then find the x value where the tangent is horizontal. So have a try. So let's try the first one. Split it. That's using algebra. And then you simplify 3x plus 4 minus 7x power negative 1. And then let's differentiate y dash equal 3 plus 0, double minus is plus x power negative 2. And then you will get this 3 plus 7 over x squared. And you have to make that equal to 0. And if we look at that, let's try to solve it. 7 over x squared equal to negative 3. 7 equal to negative 3x squared. X squared is negative. Can that be negative? The answer is no. So that means no solution. So which means that if no solution means there's no x value where the tangent is horizontal. So the tangent is never horizontal for this graph. No tangent is horizontal. All right, try the next one. Next one you will get an answer, but this one you won't. That was deliberate. So you know that not necessarily every question have an answer. You could have no answers. And note also that this one, when you see that, that's positive, it can't be 0, right? So you can already deduce from here that the derivative is always positive, therefore that can't be 0, which means you can deduce that straight away. If you can do that as well, that's available. Try the next question. Have a try the next one. Our next one's a bit tricky. You have to split the fraction. You have to use the stuff. So let's see. So split into 2. 12x on root x minus 6 on root x. This one you can use index for x power half minus 6x power half. Subtract 1 minus half x power negative half, which is 12x power half minus 6x power negative half. Like that, before you differentiate. So the algebra take up most of the work. Y dash equal half times 12 is 6, negative half, because subtract half by 1 is negative half. Times these two, you get 3, x power negative 3 over 2. And then make that equal to 0. Okay, yeah. No, I didn't. Okay, that's okay. All right. 6 over x power half plus 3 over. Now the equation gets a bit more tricky when it involves fractional index, but we'll do one thing at a time. All right. So the half is root x. Which again, when we solve the equation, we do not want negative index nor fractional index because that will complicate things. The other one, 3 over 2, notice is 1 and a half. And if we do x power 1 and a half, it's same as x power 1 times x power half, which is just x and root x. So this thing is x root x. So we'll get rid of the fractional index. And then we'll move things around. So maybe I'll move this term to the right, which is equal to negative 3 over x root x equal to 6 root x. And then what we do is we multiply both sides by x root x, that will cancel. So 6x equal to negative 3, which means x is negative half. So find the x value where the tangent is horizontal. Now I got that from the textbook. I just checked. This is the answer. This was the question. But can anyone see what that problem is? I mean, we did everything correctly. What's the problem? Yep. Yeah, you can't put it back in, so it doesn't really exist. So in that case, there's no x value that works. So you must work with the original one. There's no y value because the domain, if you look at it, is x bigger than 0. That's your domain. And if you find it, and sometimes when you find stationary stuff, you may find something outside the domain, and you do have to realize that. So in that case, it's the same, different reason. You will say No tangent horizontal. So yeah, that was a yeah. All right, so just be careful. In the textbook, they didn't say anything. They just said -1/2. All right, start to work. There's 2 exercises you have to do. Start now.